right, and solve an absolute value inequality for this situation. Your car averages 31 miles per hour on the highway, but the actual mileage varies um, from this average by at most 5 miles per hour. So what is your range of mileage? So you could be getting more than 31, you can be getting less than 31, and it's at most 5 in each direction. So it could be that upper bounds. Now, just intuitively, if you look at this, um, if I take the 31 and I add 5, notice I'm at 36. And if I take the 31 and I subtract 5, notice that I'm at, what the heck is that, 25? I'm at 26? Is that right? I guess it is 26. Um, so the answer to this question, right? It says, what is the range? Well, it says, and by the way, it does say at most. So I think the answer is, hey, here's my x's. My x's are more than 26, or um, they're greater than or equal to 26, but they're also less than or equal to 36. So that's the answer, right? Now, how do we set this up and solve an absolute value inequality? Because that's what we're asked to do. Well, let's look at it. The so let's say that my mileage is this, my actual mileage. And I know I'm just going to subtract from that the 31. So what that is that's the difference between my current mileage and my average mileage. And I know that it varies by at most 36. No, I misspoke. It varies by at most 5. So this difference right here can be no more than 5. It can be 5 or less than 5. So it's an absolute value inequality, and you can see it's less than, so it's going to be joined by and, which definitely agrees with this solution that we got. So I've got two inequalities we consider. One of them is x minus 31, and then I'm going to flip the direction on this side, and I'm going to write negative 5, right? Keep flip opposite, and I'm going to keep this the same, keep this the same, and keep this the same. So if you look at this on the each side, I'm just going to be adding 31. So over here, if I add 31 to both sides, I get x's have to be less than or equal to 36. That's interesting because that's part of what we had over here. And the other one is if I add 31 to both sides, I get x's have to be more than or equal to, greater than or equal to 26. And that's exactly what we got if you're looking at this thing, right? Reading it the other direction. So because this is joined by and, right, I can put them in this combined inequality that's exactly like this. Also on a number line, if I'm looking, here's the number, I guess this is the number 36, and I'll say over here is the number 26. These are both solid dots, and my x values are all of those things that are in between those. So any x's I pick in that range would satisfy this inequality. So, you know, thinking about the problem, they're kind of intuitive to solve. So it's always good to kind of do that and realize, oh, I can reason through this, but at the same time, kind of develop this systematic approach for doing it because sometimes my intuition or this reasoning process will fail me. If I invest in this tool, it always works, right? I don't have issues with that. Anyways, that's question 19.